Hi, and welcome to Tech Lightning. Today, I'm diving into the security segmentation as defined by the Microsoft Well-Architected Framework, WAF. Why does security segmentation matter? Stick around, and by the end of the video, you'll not only understand the concept, but also how to implement them effectively in your Azure solutions. So here we go. This segmentation that I'm about to explain comes right from the security pillar and the Well-Architected Framework by Microsoft. This framework is a set of guiding principles on how your workload should be configured in the public cloud. Wait a minute. Is this part of the Cloud Adoption Framework, CAF, by Microsoft, you may ask? Well, the Well-Architected Framework, or WAF, is actually a separate framework compared to the CAF. The Microsoft CAF is focused on giving a roadmap, guidance, and tools to help organizations plan, adopt, and govern cloud adoption strategies. The WAF, it has principles focused on the best practices for your workload in the cloud. In other words, we can say that the CAF guides you through the journey of cloud adoption, while the WAF helps you evaluate and improve the workloads in the cloud. Looking at the WAF, we see that it has 5 pillars, which are reliability, security, cost optimization, operational excellence, and performance efficiently. In this episode, we will focus on part of the security pillar, which is where the segmentation comes into place. The WAF segmentation definition is the following from Microsoft. The segmentation strategy must include network, roles and responsibilities, workload identities, and resource organization. So segmentation can be defined as a logical section of your solution that needs to be secured as one unit. Let's say you have an application accessed from the internet. This application usually has a front-end system, which the users are accessing and can then be considered a unit. The front-ends communicate with a back-end contains the business logic and even the data. This can be considered as a separate unit, as you will have different security measures for the front-ends compared to the back-ends. A segmentation strategy defines how a segmentation unit, for example the front-ends, have their own security requirements and measures. The back-end is another unit with their own security requirement and measures. We have different services within Azure which can facilitate this type of segmentation. Let's zoom in on the identity part. This is Azure RBAC, where you can segment and isolate access based on job function. For example, a certain group of employees only need read access to your unit, while others need contributor access in order to manage it. Enter ID is key in segmentation using the identity. Looking further, we stumble upon the next segmentation block, which can be done on the networking level. In Azure, we have the following services available for us to help. We have virtual networks, which provide a network-level containment of resources and a hard traffic boundary unless explicitly allowed with other networks. We have network security groups, NSGs. These are an access control mechanism for traffic in the virtual network and to external networks. In other words, it's a firewall which allows you to define the traffic that is allowed or not allowed. We have application security groups, ASGs. They allow you to easily group a set of resources, for example, virtual machines, and then have the traffic rules in NSG be based on these groups. We have user-defined routes, UDRs. Here we control, for example, the next hop for traffic. If your unit needs to communicate with others, the next hop can, for example, be a firewall or another device to secure and inspect your traffic further. We have Azure Firewall, which is a full-fledged firewall to control and inspect your traffic. Azure allows us to apply several network segmentation strategy patterns. However, there are 2 which are highlighted in the WAF, which we will look at here. The first pattern, pattern 1, is segmentation within a workload, soft boundaries we call it. Using this pattern, the workload is placed in a single virtual network using subnet as boundaries. There are NSGs on the subnet, in this example on subnet 1 and 2. You must configure NS keys that allow subnet 1 to only communicate with subnet 2 and subnet 2 to only communicate with, for example, the internet. The other pattern is called segmentation within a workload, and an example of platform-level segmentation. Workload components are spread across multiple networks without pairing between them. All communication is routed through an intermediary that serves as a public access point. This can be when, for example, when a virtual network 1 hosts an API that is exposed externally. Virtual network 2 hosts another system, such as a microservice, that consumes the API using the public endpoint. The pattern provides containment, but has the trade-off of additional virtual network management and sizing. There is no internal communication within Azure between these two networks. So the two networks can be paired, but then you break in the segmentation by connecting them to create one larger segment. This can and should be done in some cases when there are no other public endpoints that are needed. So that was network segmentation in a nutshell. Another way to segment things are based on resource organization. Imagine you have an Azure environment which contains multiple workloads and shared service components. The shared service components can be resources such as the Azure Firewall, DNS identity service within Entra ID, and, for example, Microsoft Sentinel as a security service. Components should be grouped based on their functional areas, workloads, and ownership. For example, the shared networking resources should be grouped together in a single subscription and managed by the networking team. Components that are dedicated to individual workloads should be in their own segment and might be further divided based on application tiers or other organizational principles. You grant access to manage the resources within these individual segments by creating RBAC role assignments. For example, the cloud networking team might be granted administrative access to the subscription that contain their resources, but not to the individual workload subscriptions. The bottom line is that a good segmentation strategy makes it possible to easily identify the owner of each segment. That's where you can use Azure resource tags and identify and set the owners per resource in Azure. So, when granting access, you always need to follow the principle of least privilege. Also very important, and I see this oftentimes forgotten, is to make sure you make a distinction between the control plane versus the data plane. Control plane is where you manage the resource itself on a platform level. For example, that is setting up an Azure SQL database, configure its replication, backup, security settings, and other options that has to do with the platform. However, just because a team has access to that level to configure the resource doesn't mean they should have access to the sensitive data in the database. That is located in the data plane. Another team will then have access to actual data in the Azure SQL database. So it's very important to keep this distinction while you architect your identity and access solutions. This wraps up this episode of Project Stack Lightning. If you are ready to take your cloud security to the next level, check out the links in the description for more on the Microsoft Well-Architected Framework and security segmentation. Do you have any questions on our insights? Well, drop them in the comments below. I would love to hear them from you. Don't forget to like, subscribe, and hit the bell so you never miss an episode. Thank you for watching, stay secure, and I'll see you in the next one.